temperature is an incredibly important measurement that we do throughout chemistry. And we use three main scales. You're probably familiar with the Fahrenheit scale. There's Celsius and Kelvin. Fahrenheit and Celsius are both degree scales. So these scales both have zero temperatures. So the zero over here, round up, and they go down to negative values and positive values. So both Fahrenheit and Celsius have those types of values. Fahrenheit we use very rarely in chemistry. Mostly we use Celsius. This is our metric calculation. We also use the Kelvin scale. The Kelvin scale is a little bit different because it starts at absolute zero. So if you ever find you've calculated a value of Kelvin that is less than zero, so a negative value, no, that's not correct. If we look at a comparison of each of these scales, in Fahrenheit, 32 degrees Fahrenheit is the freezing point of water. For Celsius, 0 degrees Celsius is the freezing point of water. And in Kelvin, 273 Kelvin is the point at which water freezes. Okay. These are also the temperatures at which water melts from the ice to liquid water. For both the Celsius and Kelvin scales, there's 100 between the freezing point of water and the boiling point of water. So the freezing point of water in Celsius is 0 degrees Celsius. The boiling point is 100 degrees Celsius. It was set this way to make it easier to remember, a more convenient measurement. In Kelvin, since the Kelvin temperature for water freezing is 273 Kelvin, that means that the boiling point of water in Kelvin is 373 Kelvin. Now, you wouldn't necessarily use these scales all at the same time, so we need some way to convert between. We often need to convert between these measurements because there may be times when you need to use Kelvin, but you're never going to find a thermometer with Kelvin on the scale. You would need to convert from either Fahrenheit or Celsius. Often you may have measurements that are Fahrenheit because that's the most commonly used in the United States, and you would need to be able to convert from Fahrenheit into Celsius or vice versa. This is the equation that tells us how to convert between Fahrenheit and Celsius. TF is the temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. You may be familiar with this equation from K-12, so prior in your education. If you're not, you do want to make sure and practice with it and work with it. Make sure you have that available whenever you're doing your exams and such. Celsius and Kelvin. For Kelvin, you take the Celsius temperature and you simply add 273.15, or sometimes it's just written as TK equals TC plus 273. It would depend on your significant figures. If your initial temperature in Celsius or Kelvin is recorded to just the whole number, you would just need the whole number value. If it's recorded to 2 decimal places, you can use the 2 decimal place value. For temperature conversion, we want to work through how we would convert 65 degrees Fahrenheit first to degrees Celsius, then we're going to convert that answer to Kelvin. So first we're going to convert to Celsius. So I want to convert my 65 degrees Fahrenheit to degrees Celsius. I need my equation, temperature in Fahrenheit equals 1.8 times Tc equals plus 32. I need to rearrange my equation to solve for temperature in Celsius. To do so, I'm going to subtract 32 from both sides. That will get rid of my 32 on this side. I need to get my temperature in Celsius by itself, so I'm going to divide both sides by 1.8. Gives me a final equation of temperature in Fahrenheit minus 32 equals over 1.8 is equal to temperature in Celsius. Now I can simply substitute in my 65 degrees Fahrenheit into my equation. 65 minus 32 divided by 1.8, and that gives me 18 degrees Celsius. So that's my T and TC, my temperature in degrees Celsius. To convert that to Kelvin, I simply add it to 273 or 273.15. Either way, we're going to get 291 because remember, when we add, the significant figures are based on the place value. We have this as a whole number, so we need to round our final answer to a whole number because we're working with addition or subtraction. I do suggest that you do some practice of these temperature conversions. Here's a few more for you to try on your own.